Good afternoon, everyone. In the previous class, we have seen some vector basics regarding how to locate the points in the three-dimensional rectangular coordinate system specially. Okay, this was the example, and we have seen the resolution of a vector in detail. And this was the problem solved in the class, how to find the unit vector for a particular point. Starting from the origin, one task was given to you, how to locate this point in the three-dimensional coordinate system where this point G comes. So I hope you have done this. Then this was the homework given to you. I hope you have solved this problem. If you have not solved, I will be sharing this file in the Google Classroom and HRMS. Please go through it. If you don't understand anything, you can ask me through WhatsApp, or you can personally message me. This is this problem solution. I have solved it. I have got the answers. One more example. Let us start with this example today. If you see, this is a three-dimensional rectangular coordinate system. I have marked the points. P is a point in space. Okay. We have to find this OR, the distance of this point P from the origin. That is R vector we need to find. How can we calculate? So let us try to find the value of R. In order to find this value, we will make use of some vector basics. We will extend one foot perpendicular dragging from point P. And if you observe this line and this line, they are parallel. Okay, Z axis and this P dash. Okay, point P dash, they are parallel. And there is one more line here drawn, a diagonal you can say, OP dash. So that if you observe here, we will be getting two different triangles. One is POP dash, okay, O is the center. And there is one more triangle here at the base, that is QO and P dash. So two triangles are there. So we will start working on those two triangles in order to get this. Okay, one point we know that this is the perpendicular line to the parallel to the axis Z. And if you see, I have marked here XI, YJ and ZK. What are these? X, Y, Z are some magnitudes. Okay, that length is that. And IJK represents the unit vectors in those different directions. XI indicates the X magnitude in X direction. That is, X direction is specified as I unit vector. Similarly for Y is the magnitude and the unit vector direction is J cap, and then Z, K cap. These are the values, and we need to find this R, magnitude of R. So let us start with the triangle POP dash. So which is that? POP dash, that is this triangle we will start with. So what is OP equals to? Vector addition, you know it. OP dash plus P dash P is equal to OP. See, these two are in the continuous direction. Add these two lines equals to this. That's what I have written here. That you denoted equation 1. We want OP, right? That in that, if you observe, you have OP dash line, this line, and PP dash line. So PP dash, you know it already, it is parallel to the Z axis, and the Z axis value we know it, it is ZK cap. But OP dash is not known to you. So in order to find this OP dash, we will make use of one more triangle at the below, the base. So how to continue that? This is one thing already we have seen. Now let us consider the base triangle, QOP dash. So consider this triangle. In this triangle, if you again see the OQ line, OQ plus QP dash, both are in the continuity in the direction. So these two is equal to OP dash. OP dash is equal to OQ plus QP dash, right? And what is OQ? This is a line x I cap. Okay, x I cap substituted. What is q p dash? Q p dash, it is a line parallel to this y axis. So it is y j cap. So y j cap. Substituted both the values. Once we substitute these two values, see here. So we have got pp dash, we have got op dash. pp dash and op dash. If we add these two, we will get the distance between point P and O, that is OP, small r. So just add both the values, you will get xi plus yj plus zk. X, Y, Z are some scalar magnitude values and I, J, K are the unit vectors. So I hope you understood this simple problem, how to find the distance from the point P to the origin. Similar to this earlier one problem which we solved here, this problem, point G is given to you, you have found out the unit vector in the previous session. Similar to that, one more example is taken here, you can see, find the unit vector in the direction of A. There it was G, here it is taken as A. A is given in this form. How to find the unit vector? Unit vector is equal to the vector given divided by its magnitude. So magnitude I have calculated. What is the magnitude of this unit vector? It is square root of 2 square plus 3 square plus 1 square, right? Which is square root of 14. And you can calculate what value you get, you write it. So what is A cap is equal to the given vector divided by the magnitude. Again split this among all three directions. 2 by, let me just take a different color. Okay, 2 by square root of 14 I cap plus 3 by square root of 14 j cap plus 1 by square root of 14 k cap. This is your unit vector. Simple. Now coming to the next topic, important one, it is scalar field and vector field. In the introductory classes, we have seen what do you mean by a physical quantity, what do you mean by scalar quantity and a vector quantity. What is a scalar quantity? It is having only magnitude, maybe any positive or negative number. In magnitude, we represent this scalar quantity. For example, I had told you temperature or say length or your height of your body. You cannot say that your height is say 5 feet 3 inches in this direction. You cannot give any direction to your height. Similarly, length of any particular material. So you cannot say that the length of this material is so and so in this direction. So direction you will not specify in scalars. But in case of vectors, direction is very important. The example I had given you was the force. Force, centrifugal and centripetal force. Two different. So you mention the direction. If you are applying any force, in particular direction, what is the force? So direction is important to define the vectors. Now coming to the scalar field and vector field, what do you mean by a field? Field is generally specifying a region, a specific space, that is called the field. Okay. So if you associate a scalar word with the field, a scalar field, how will you define? You know that field is nothing but the space and a scalar, it is a magnitude. So conjoining both these, we can define scalar field as the region or the space where a scalar quantity is distributed. Let me take you a specific example. If I take one container, okay, you can take any of your utensils which are in the kitchen. You find it in the kitchen. Take any utensil, keep an ice cube inside that utensil. Now, if you put this ice cube inside this utensil, how will you tell, what is the temperature of that utensil? if you have already studied chemistry, the atomic structure, how the molecules behave, you know, the gaseous state, liquid state, solid state, you have studied this already. So you know that molecules, how they are distributed. So if you see just exactly, you know, very close to this ice cube, the temperature will be different. And if you just observe very far from this ice cube, the edges of this your utensil, the temperature will be different. No doubt, in general, we say that temperature is one physical quantity. But are we sure that this temperature is uniform throughout? No. Near the ice cube, temperature is little less. Surrounding your edges of the utensil, the temperature is little bit more. Okay. Even if you take you know, your room or any classroom, the room temperature generally we say that it is 25 degrees. But however, if you just um, observe it very carefully, when the room is you know, closed, with the doors closed and windows closed, if you suddenly open the windows, at the near this windows region, the temperature will be little bit different than the center of the room. So this temperature distribution, temperature is a scalar quantity and its a distribution in a specific field, that we call a scalar field. Okay. Example I have given here, one more, the temperature of hot water in a container. Again, if you pour hot water on the surface, in the middle, or at the below level, the temperature is different due to the molecular structure. Okay. And one more is ice cube kept in a container. This is about the scalar field. Now regarding the vector field, this vector field, what example I am going to give you now, you will understand this when we deal with the electric field intensity concept. But you just now understand the example of vector field. Vector field, again, field is a region or a space where the distribution of vector is associated. So you know what is a vector? It is having both magnitude and direction. So it is a function or a region of space whose value at each point, it is definitely a vector quantity, and over the field that vector quantity is distributed. It is not same. Okay, it is having different values in that particular space. And that quantity, just like in the previous example I have taken the temperature, the vector quantity, it is not same. Let me take one example. This is your three-dimensional coordinate system, rectangular coordinate system. If I take here some point P, just now you have calculated one example, this length R, okay? P is having certain coordinates, say 1, 2, 3. Okay, let me take this one example. If you try to find the electric field at this point, you will get some value. Okay. Now, if I change the position, okay, if I take point somewhere here, P, and these coordinates are say 2, 3, 4, then if you observe, this length will be different. Okay, this vector will be different. And if you calculate the electric field at this point, it will be different. These two fields will not be same. They both will be different, and electric field is a vector quantity. Similarly, magnetic field, always direction will be associated with the electric or magnetic fields. Hence, the distribution of this electric field or magnetic field over a certain space, over a certain region is the example for vector field. I hope you understood the scalar field and vector field. Any doubts? Can we move to the next topic? Any doubts? You can just unmute and ask me, or I'll move to the next topic. Yes, no doubt. Good. I'm really happy that you're understanding. Now coming to the next, this was actually a part of the assignment which was given to you when I was dealing with the vector algebra. addition, subtraction, multiplication and division I had asked you to go through regarding the vectors. This is one part of that assignment, that is vector multiplication. Okay. Coming to the first, there are two different multiplication aspects in vectors. You have already studied this, probably in physics. One is the dot product of two vectors. Okay. Dot products, it is also called as scalar product, because when you are taking the dot product of two vectors, you will get it is a scalar quantity. Now, given the two vectors A and B, the dot product or the scalar product, it is defined as the product of magnitudes of those two vectors A and B and the cosine of angle between those two vectors. This definition, I have written it in a equation form. A vector dot B vector, this dot is not the multiplication, it is indicating the dot product. It is equal to magnitude of the first vector into magnitude of the second vector into the cosine of angle between those two vectors. Here I have taken theta as the angle between A and B. So this is dot product. It is a scalar quantity and it obeys commutative and associative law. Both are applicable. If you exchange A and B, the answer you will get same. And few observations are made here. You can just go through it. First is, if A is perpendicular to B, if you are having two vectors like this, theta is 90 degrees, then A dot B, that is dot product, is 0 because cos of 90 will be 0. And if both are parallel to each other, something like this, okay, they are coinciding or in opposite direction like this, okay. So theta is either 0 or 180 degrees, pi or 0. In that case, cos of 0 and cos of 180 degrees, you have to substitute. You will get magnitude both A into B or minus of A into B, because cos of 180 degrees is minus 1. Then if you are having unit vectors I, J, K, generally I, J, K is used, and in your Haytenbach textbook, either they are using IJK or sometimes they are using AX, AY and AZ as the unit vectors. Notations, please, be familiar with. Now, what is the dot product of the same vector I dot I or J dot J, K dot K? It is equal to 1 because the angle between them will be what? 0. Cos 0 will be 1. So I dot I will be I. J dot J will be equal to 1. K dot K is equal to 1. So the dot product of one vector with the same is equal to 1. And what is the dot product of two vectors I dot J? Because we know that how the unit vectors are distributed. How the unit vectors are distributed. They are perpendicular to each other. See, this is J, this is I, and this is K, I, J, K. If you are taking the dot product of any two unit vectors, the angle is 90 degrees. So cos of 90 will be 0. Hence, the dot product of two unit vectors, it is 0. And we know that this is the dot product equation. From this, you can calculate the angle theta. It is the cos inverse of dot product divided by their magnitudes. And dot product is associative and commutative. So this is about the dot product. Coming to the cross product. Given two vectors A and B, the cross product or the vector product, dot product is called the scalar product, cross product is called the vector product. It is defined as the product of, just a second. The cross product, it is defined as the product of magnitudes of two vectors, that is A and B, multiplied by the sine of angle between them. Okay, this is how A cross product is defined. There it was cos, here it is sine. And one more thing is important here, that is the unit vector. Unit vector in the direction of that product. And that a suffix capital N. This N indicates that the vector, this A cross B, the answer what you get, it is perpendicular to the plane containing those two vectors. The actual direction, it is obtained how? We have to apply right hand corkscrew rule. You can see it below. Here I have drawn, I think it is visible to you. Let me just draw it. This is the plane which is containing both vectors A and B. This is the angle theta. If we take A dot, that is A into B into sine theta, then this is your screw. Okay, I hope it is visible to you. Okay, if the screw is rotating in clockwise direction, then this below is your direction of the product. So this is indicating your AN direction of the cross product. Okay, this is your right hand corkscrew rule or right hand rule. Now some observations based on the cross product equation. If A is perpendicular to B, that is if both are perpendicular, theta will be 90, sine theta, sine 90 will be equal to 1. So A cross B will be equal to multiplication of two magnitudes. And if both are coinciding to each other, then theta will be 0, then sine 0 will be 0. Cross product of those will be 0. Now if we consider ijk unit vectors, then it is opposite of that. I dot I was, dot product was 1, 1, 1. Here I cross I will be equal to 0, 0, 0. Okay, cross product will be 0 of the same vector, because theta angle will be 0, sine 0 will become 0. This is one important difference. Then if you take the cross product of two different unit vectors which are perpendicular to each other, see this is your J, this is your I, this is your K, then I have written here, let me just write it one more time, I, J and K. You just take the arrow marks in this way. It is easy for you to get the third value. If you are taking I cross J, the next value will be K. So it is I cross J equals to K. Similarly, if you are taking J cross K, the next value will be I. Then K cross I, the next value will be J. Fine. Now, if I take J cross I, reverse, if you take reverse of this, J cross I, you should get K, no doubt, but as the direction is reversed, there will be a negative sign. Okay. Similarly, J cross K. What is J cross K? It is I. But if you are taking reverse, K cross J, you should get minus I. So, from this, you can understand that it is not commutative. Okay. There will be a negative sign. That's what is written here. You can see A cross B is equal to minus of B cross A. And from this equation, you can find out the angle theta, sine inverse of this. So this is about the cross product. I hope you understood this. I think time is running. So can I end this session? We can rejoin it. Please rejoin as early as possible so that we can take one more session as for now. I'm ending the session. Thank you. The second session, please rejoin.